Hello and welcome to the video on definite integral substitution method things. So it's basically the same thing as indefinite integrals, but a little different, so not the same. So I'm taking these straight off the worksheet. So 31, our function is y equals square root of 1 minus x. And the worksheet says area between 1 and the coordinate axes in the first quadrant. So we're bounded by the lines y equals 0 and x equals 0 because we have to be in that first quadrant. So if we plug x equals 0 to that, we get square root of 1 minus 0. So we get y equals 1. So that coordinate is 0, 1. If plug in y equals 0, we get 0 equals square root of 1 minus x, square both sides. 1 minus x equals 0, x equals 1. So in this case we have 1, 0. So our x values are 0 and 1. That's what it's asking when it says first quadrant. You have to plug in y equals 0 and x equals 0. So now we can actually start the integration. So we want the integral from 0 to 1 of the square root of 1 minus x. And I'm going to do this a long way around. And then I'll do the shortcut and explain kind of how it works. So in this case, u equals 1 minus x. du equals negative 1 dx. But there's no negative 1 here. So we have to divide over here. Negative 1. So we want negative 1, the integral from 0 to 1 of u. Remember, that's to the 1/2 du. Well, that would be 2/3 u to the 3/2, right? So, right now we want negative 1 times the quantity, 2/3 1 minus x to the 3/2, minus 2/3 1 minus x to the 3/2. Obviously, we're going to plug in those numbers. So, here we have 2/3 1 minus 1 to the 3/2 minus 2/3 1 minus 0 to the 3/2. Remember, this is all times negative 1. Well, 1 minus 1, that's 0, and 0 to any power is 0, and 0 times anything is 0. So that's 0 minus 1 to the 3/2 is 1. So 2/3 times 1 is 2/3. So we have 0 minus 2/3, which is negative 2/3, times negative 1 is 2/3 as our area. And the way it's going to look on a graph is kind of like that. So you can imagine it's not a complete square from 1 to 1 here, but it's kind of close. So you can see it's about 2/3 of that area. Okay, the next question, or the next problem from the homework, is number 25. Y equals cubed root of 1 plus x. Kind of the same thing. Not really. So, I'm going to do this actually, I'll do this the shortcut way first, and then I'll do it the long way around. So, it's asking us from x equals 0 to x equals 7. So, we want the integral from 0 to 7 of the cubed root of 1 plus x dx. So, shortcut dictates that we find u, which is 1 plus x. Then we plug each of these values in. So this is 8, this is 0. Not 0, this is 1. 1 plus 0 is 1. So then we integrate. We have u to the 1/3, which becomes 3/4 u to the 4/3. But this time, instead of plugging 1 plus x back in for u, we do this. We take 3/4 times 8 to the 4/3 minus 1 to the 4/3. So we take that out in front, and then we plug these values into these powers. So we get 3/4. Well, a cubed root of 8 is 2, and 2 to the 4th would be 16. Minus 1 to any power is 1. So that's 15 times 3 over 4, which equals 45 over 4. Now let's remember that number on this page. 45 over 4. And now let's do it the long way around just to make sure that this substitution mojo works. So at the integral from 0 to 7 of the cube root of 1 plus x, u equals 1 plus x, du equals 1 dx. If we have an integral from 0 to 7 of u to the 1/3 equals 3/4 u to the 4/3, and I think you can kind of see how this is working out. So now we have 3/4 1 plus x to the 4/3. So we have 3/4 1 plus 7 to the 4/3 minus 3/4 1 plus 0 to the 4/3. 3/4 times 8 to the 4/3, remember, was 16. 3/4 times 16 minus 3/4 1 to any power is 1. So that's just 3/4 times 1. So that is 16, so that's 12 minus 3/4. So 48/4 minus 3/4 equals 45/4. Is that the same? Oh yeah, it is. Okay. Now you can kind of see why this works, because right here we're plugging these values in again, so it's almost like we're factoring that 3/4 out, and then we're plugging those values in. So we basically did our work early, and now we can just plug things in. So that's how integral substitution works when you're talking about definite integrals. Thanks for watching the video. Drop a like or a comment if you enjoyed it. That's all. Bye.